all are successfully and properly, like thinking about what is my brain doing, and then translating into code. But whenever you don't, that's when I kind of see like wrong turns and weird directions. So as much as you can, like now is the time to build that as a discipline. All right. So even if you want to just jump in and start writing code, let's use this as a learning opportunity not to do that. All right. So one of the challenges I'd say with these problems and with LeetCode in terms of that approach is just that they give us the answer, so it like almost doesn't give our brain that problem solving ability. So what you can do, and what I would almost recommend, is give yourself a new problem. All right. So if I give myself an array of like 8, 7, 3, 9, 1, and now I say k equals 3. It's like, what's the answer? Well, we all, I feel like, are noticing the pattern. If we take these last 3 numbers and move them to the front, and then we take the remaining numbers and move them to the back. Right, so I'm literally just going to write this in comments, and then I can even break it down further. Take the last 3 numbers, move to the front, take the remaining numbers, move to the back. Right, and then what I can do is just, all right, well, how I do this in code, where we can start with array of 1 up to 3. And I'm always just checking my work as I go, because I like forget if this stuff will actually work. So, okay, and then you can start to notice the pattern, right? This is up to k. So I did it wrong, I think. It's take the last 3 numbers. So it's -3 colon, right? -3 on. I think -1, -2, -3. All right, so now this is starting to match, right? And it's nice that I wrote the answer out beforehand because it allows me to like check my work as I go. Take the last 3 numbers. Take the remaining numbers, seems to be the next easiest. So that's going to be, if this is 391, remaining numbers are these 2, right? And that's 8, 7, array of 1. And now this is going to be 0, 1, and that's kind of interesting. Oh, I'm wrong. 0, 2. Okay. So for this is obvious. Now the next thing we want to do is kind of like, we can add this together. We can call this like first part, last part, right? And we want to take this first part, 873, and move it to the end, right? And take the last part and move it to the beginning. And now we got to the answer. But what we want to do is put this in terms of k. So this part's easy, right? Because you can just see the pattern. And -3 turns into -k is the last 3 numbers. And then this one's a little harder, but what it seems to be is like the remaining numbers. So what are probably the remaining numbers? Up until the last 3. So it means like take the length of the list minus those last 3. So that's how we can probably get to, like the length of array 1 minus k should give us 2. And I'm guessing that's it. Yeah. So that's fine. So you can see what we did. We just do the answer, break it into steps, write out the comments, solve each comment individually. I did it like easiest to most hard, I suppose. And then go from concrete to more abstract. Okay? And check my work along the way. Because I feel like, especially in an interview, we can always make a mistake, and then, it's a little easier if we just move slowly and check our work and isolate where that mistake is occurring, rather than leave it for the end and then have to debug it. Oh, I want to switch it? Switch both parts? Did I do this wrong? Oh, I did do it wrong. So it's 391 Oh, because what am I selecting here? Let's see what first part is. First part is really the last. Yeah, the first part is actually this. So 391 plus last part. There you go. 391 plus 87. Cool. The other thing I did, you could see, like, I wrote this in the solution, was I was like, oh, well, we can think of this as changing the index, right? So it's like, what does the index start at? And then what does it end at? And again, I was just like, it's too hard for me to think of this abstractly. Let's make this as concrete as possible and then make it abstract. So it's that same exact technique of start with something concrete, then find the pattern. And it helps me avoid making mistakes. 2, 3, 4. So this is the original set of indices, and then this is where I go to, right? And so to get there, how did I do this? So this part, 873, the new index of this, k equals 3. Okay. So this becomes my new 0, 1, 2. And this 8, 7 becomes, I basically 0, 1. This becomes 0, 1, 2. This becomes 3 and 4. Okay. So now almost like a logic, I think, like reveals itself, which is, oh, you just take this, and you take the original index and add k to it, and that's the new index, right? This becomes 3, this becomes 4. This one here should become 5, but there is no index 5, right? It's 0, and the last one is 4. So you kind of start over. So what's the way of starting over is just subtract the length of the list, right? So it's really, you could think of it as 3, 4, 5, 6, 7, but then once this is greater than the length of the list, minus 1, subtract the length of the list to start over, right? 0, 1, 2. So it's like 4 element, or actually index, comma element, in the list of elements. What do we call it? Array 1. What we want to do is let's give myself a new list, return list, right? And I'm going to want to go through each one of these numbers and say that this guy should be in this, this element should be in the third slot, right? So what I want to do is say return list of index plus 3, right, plus k equals the element. So, but that's only up until, I guess maybe it's k plus 1. I'm not sure. It's only up until, it's only so long as the element we're adding, right, is less than the length of the list, right? So if, we'll call this the new index. So if the new index is less than the length of array 1 minus 1, then we'll set this here. I know we're going to have to first populate it with null values. Otherwise, I think what we'll want to do is take the new index and subtract the length of the list, right? Take the new index, like 5, 6, 7, and subtract the length of the list to bring it down. I'll just say new index equals the new index minus the length of the list. I'm not sure, we can see we can do some refactoring here. We're going to have to populate this list. By that, I'll just do none times by the length of the list. So I'm going to populate a list of null values, then go through each element in the array, right? Each element in this array, and set in this list, set this list, the index, let's say at position 3, should be the value of 8. Okay, so that's what I'm doing here. Except when I get to a number that's higher, and now it should be to this position, like 0. Let's see if it works. I broke it. For index, oh, this needs to be enumerate. Sorry, gang. Is this right? 39187. Yeah. Okay, so what did I do? Again, it's like this technique of, okay, well, I guess what I'm really doing is I'm changing the indices. Is there a pattern if I just like look at this concretely? All right, of what to take this element, set the new index to. So I just wrote it out. What's the original? What's the new one? And then I can start to see, or sorry, here's the new one. And maybe originally there's like no pattern. Then I can start to see, okay, well, really this should be like 5, 6, 7. Why is it not that? Because, that would be too far. So we can kind of reset it. So I'm just leaning on I guess one of the things I want to stress is like, especially with this solution, I don't know when I started doing this, I have no idea what the pattern is, right? I'm just leaning on the process and the process anyone can do. You're just writing out the numbers. And the process is be concrete, then see if there's a pattern. Okay? And write it out in front of you, because I don't have to hold on to this information in my head if it's written down. I can devote my energy towards looking for a pattern now. Questions about this, or otherwise we can move on to the next one.
What's the main approach if you're using nested loops? Is it okay for these things, or should we try to avoid them? Or
well, we're not.
Maybe it wasn't possible in this one.
I mean, we're not using a nested loop in either case, I don't think. Right? We're only going through this list one time. Do you mean if for a different approach?
No, I guess I was getting confused since there was if.
Yeah, there is an if else, but we're, and even this like this part's duplicated. Like I could basically just say if the length, like we can refactor this at this point. Let's do that. Because what I could do is really notice that in both cases, in both branches of the if statement, I'm setting, right, the element right here. The only thing difference is when the new index is greater than the length, greater or equal to, I guess, the length of the array, then I want to reset the index, right, to be, basically if I get to a number that's like 5, 6, or 7, I want to chop it down to 0, 1, or 2, right, and then always set the element. So that's what I'm doing. So I just refactor the code for that, right? Go through, get the element plus k, but in the cases where I get higher than 5 or equal to 5, right, chop it down by removing the length. And let's just see, does this work? And that works too. So we made this now just an if statement. But you can see, like, I'm only refactoring it after I check to make sure it's... do you have an in-place solution? I was thinking about an in-place solution. So actually, in real life, I tried an in-place solution for this without creating a new list. Generally, okay, so let's start Any questions before I show my attempt at an in-place solution, which I don't think it's possible. Maybe someone else did it, but I couldn't. Okay, so what I tried was... Okay, so we start here. Let's just start. So this is why it's kind of tempting to think of an in-place solution, because what we're doing is we're starting with one list and we're just like rearranging the order. And normally it's like, when can you do an in-place solution with something like that? Generally it's with something called like a swap, meaning that, let's say I want to flip the first and last elements, right? Just like flip these two, right? Well, that you can do in place, and I can show you. Or let's say I just want to flip these two, that you can do in place. All right, so the problem is, however, there's no swap occurring, I don't think, right? Like here, we take the 8, and the 8 takes the place of the 9, but it's not the case that the 9 takes the place of the 8. You know what I mean? So I can't just like flip them, which is what generally an in-place solution leads to. Brian potentially has an answer. Well, I think this seems to work. I think this is pretty good. Yeah, I like this. I'll put this in the chat. It's pretty simple too. By that I mean like elegant.
The algorithm has the ON squared because inserting and moving. It is the ON squared.
Is it? Yeah, it probably is.
Yeah.
Because you go through each element in the array. Yeah,
Yeah.
it probably is. It's still a nice solution, but you're right. Yeah. But it is a nice solution.
Yeah, in place is like if you do the column in front of the list, then it will do in place.
Okay. If you want to put that in the Slack, Pally, yeah, that'd be great to show some people. Let's move on. I do want to move on to the next problem. Actually, you know what? I want to move on to the... Sure, let's do buy and sell a stock. Let's see if we can get there. Okay. So, right, we all know this problem. It's basically like we have these different prices. This is like Apple stock each day. And we want to know, okay, if we buy, what is the maximum amount of profit we can make? So we want to, as we know, like buy low and sell high. All right. So what's our technique? Our technique is don't look at the answer. Have your brain come to the answer. Okay. How is my brain going to come to the answer? I start with the number 7. Like, this is just what my brain is doing. Start with the number 7 and then say, like, should I hold on to it? Or should I maybe buy? Okay? Then go to the next number. The next number 1. Do you think you should buy, kind of like replace this purchase of buying 7 for buying 1? I think you do. Like, I don't know why yet, but I know my brain is like, okay, actually we shouldn't buy 7. We should buy 1. All right, let's go to the next number. 5. And now this is kind of interesting. What I'm seeing is that I should sell 5, maybe, or like sell at 5, and profit equals, 1 minus 5. Profit equals 5 minus 1. So buy, or in other words, buy minus 1. Okay. Let's go to the next one. We have 3. And do I think I should buy at 3? Potentially. I don't know. I'm trying to think what my brain would do. Okay. 1. I think the answer is 1 and 5. I think the answer is no. Right? Because anything that came higher afterwards, I would do better with this lower price. So it seems like what I'm doing is actually like with this buy thing is I'm holding on to the current minimum, right? So here, no, do nothing basically, because I'm not going to sell because it's less than the current, current profit I could have made, and I'm not going to buy because it's not greater than the current min. And now I go to the next one, 6. Here I would sell, right? Because the profit is going to be profit equals 6 minus 1. So sorry, it's current minus the buy. Why do I keep doing this? Which equals 6 minus 1. Right? And here this would lead me to a profit of 5. And then I go to the last one, and there's nothing to do, right? I would only sell here if this was higher than the 6. So we can start to see the logic here, right? It seems like I'm holding on to a current min and then a current kind of like profit. So I want to determine where to buy by figuring out the local min, and then I want to figure out where to sell by figuring out like how much profit can I make. And that's a good starting point. It might not be totally right, but I think it's a good starting point, and I can test my logic from there. Let me see what this is. Oh, in-place solution. Let me put these in the Slack. Give me 1 second. All right, so now let's see if we can make any progress with this. So what are we doing? It seems like, go through each price. Probably set local min to initial, meaning to 7 in this case, just to the initial price. Set current profit, and this was in the problem that profit has to be like greater than 0 to 0. Okay, and so I can and then go through each price. If the min is less than current min, hold on to it. And if the profit is greater than current potential profit, whatever you want to call it, hold on to that. Okay, and maybe I'll put something that's like the sell point too, just for fun. So I can set 3 variables now, where I'll say, okay, the local min is going to be prices, just set it equal to an initial value. So set it equal to the first price as our local min, and the profit equal to 0. And then, let's also set like the buy, I guess, or sorry, the sell price. You could set it equal to like the second one if you want. I don't know. I don't know if there's a good thing. Maybe not for now. Let's leave it blank. Okay, so now what we want to do, go through each price. For a price, in prices, and we can also write down some of these. Let's copy this, because I like having it. Okay, for each price in the list of prices, if the price is less than the local min, then basically we want to say, local min equals the price. So we want to reset it, I think it's something like that. And then let's just do it in 2 lines. If the price is, so that explains to us why we would buy like at 1 here. If the potential profit is higher, we want to set that equal to our new potential profit. I think it's something like that. We have to calculate this profit. I probably won't be able to do this in time, but we want to calculate this profit, and if we get a higher number, that's like as good as we can do, or that's our new kind of max profit, running, best scenario. So let's see if we can do this. Profit I'll call this potential profit equals what the local min, kind of the buy price. Oh, sorry. The local min, this is the buy price, or it's actually the price minus what I bought at. Oh, sorry, the current price minus what I bought at. So in other words, say we bought at 1 and now we're on to 5. The potential profit is 5 minus 1, right? Giving us 4. And we want to say that we improved if our potential profit is greater than that current profit. If potential profit is greater than current profit, right? Then we want to say profit equals potential profit. Okay, we want to reset our new best profit we can obtain. So what we're doing is we're going through our prices one by one, and we're continually saying, can I do better? Can I do better? Can I find a new low at which to buy and a new kind of profit at which to sell? We'll review this in the next class, but let's just see how we do. We'll do print the profit. And let's also print the local min. And then if we get to the end, the profit should be like our answer. So it did work. Let's try to figure out how. Okay, so we go through each of the prices. If the price, this here. So we go through each of these prices, 7, 1, 5, 3, 6, 4. Set the local min to 7. Set the profit to 0. Now we start. If the price is less than the local min, right? So for this number 1, it is. Then what do? We say, okay, this is our new buy, right? Because we can improve on. We want to buy low and sell high. We can do better here. Set this to our new local min. Calculate the profit. It's always going to be 0 if we sell the same thing. But now when we move to the next number, 5, when we go through, is 5 less than the local min of 1? No. But now my profit can improve upon 0, right? So you can see my profit is 5 minus 1, the current price, so the profit is 4, right? We hit here. Now we go to the next one. The next one is 3. We do nothing because it's not an improvement in terms of buying low, and it's also not an improvement in terms of selling high. Then we go to the next one, 6. This actually is an improvement in terms of selling high, right? So we first ask, is this an improvement in terms of buying low? It is not, right? Because 6 is greater than 1. But what we can do is improve upon my previous sell price of 5 to 6. Okay? So that's why it says, okay, we did well. And then finally we print out. We get to the end of the list, and this is what I return, right? The best potential, right? As long as I keep this running total, when I get to the end of the list, what was best along the way, once I get to the end, ends up being the best overall. This is called like the greedy approach, right? A greedy approach, which is like kind of go through, and as you go through, make the optimal decision at the time, right? Like try to, I don't know how to explain it better. Try to keep improving upon that. I wrote this out. If you look at the buy and sell stock solution, I wrote this out. We'll go through this again on Thursday, and then we'll probably go through some more classic kind of data structure work with Python. And then apply that. So arrays and hashes and calculating big O of those components. All right. I'll see you on Thursday. You all did a